So now we're going to talk about how to find inverse functions. So remember the inverse is really a reflection over the line y equals x, which means that the point xy becomes yx. So we're kind of rewriting the function in terms of, well, the other variable. So what does this mean? This means if we were looking at a function like f of x equals 2x plus 3, which is the same as saying y equals 2x plus 3, right? Excuse me. This is a linear function, which we know to be, well, a function, but also being linear. It's going to look something like that, right? This is also a one-to-one function. That is, it passes the horizontal line test, so we don't need to restrict the domain. By the way, I should probably point out that the domain and the range of this are both negative infinity to positive infinity, and both cases. There's no possible x or y that doesn't happen. Now, to find the actual inverse, there's a couple different ways. I'll show you both. One is we have the function y equals 2x plus 3. I'm going to have that in both cases. There's just two different ways we can actually do this algebraically. We want to undo what's happening. Now, one way to do this is to interchange, because we're reflecting this, right? We're interchanging the x and the y, which means we now just write this as x equals 2y plus 3. No algebraic operations to do this. And then what we do is we resolve for y, which means that we would take and get everything away from y. Then we would change colors, because you have to change colors. Divide by 2, which means that y equals x minus 3 over 2. Now this is the inverse function. Remember, f inverse is the notation, right? And it is in terms of x. Notice the x is the independent variable, right? So this would be one way to write the inverse function. Usually would skip out on this y, but f inverse equals that. Here's the other way. Now if you think to yourself, I'm just undoing what's happening here. Couldn't I just solve this for x? Wouldn't that be the same thing? And you're right, because you can do the exact same process. The only difference is now you've got a y. Is that okay? Sure. Remember, variables are kind of arbitrary. So is this the inverse? Yes. Technically, though, this inverse is in terms of y, so this is the inverse of f. Remember, the f function f doubles things and then adds 3. The inverse of that is getting rid of the 3 and then dividing by 2. It just so happens to be in terms of y. Either one of these works as an inverse. In fact, if you look, they're both identical in terms of the operations. But usually we write this because if we had to graph this, we had to graph it in terms of x and y. Now, looking at both of these are both linear functions, which that no matter whether you're talking x or y, the domain and range are still the same. So we saw that the domain and range ended up being the same in both cases. Let's do another example. So this is a quadratic, 2x squared plus 3. We know it's been vertically stretched, factor of 2, so it's a little bit narrower, and it's been shifted up 3. So it looks something like that, let's say, right? Let's clean that up just a little bit. Let's make that look a little prettier. So we know that this is at 3, and it's been like that, right? We know the vertex here is at 0, 3, so let's write that down. That could be kind of important, because when we look at this, we were to draw a nice horizontal line, right? Whoops. I've gone too far. There we go. If we draw a nice horizontal line, there we go. It fails the horizontal line test because it hits at 2 points. What does this mean? It means that this thing is not invertible, at least as is. Now, under normal circumstances, if I said just invert this, you'd say, no, I can't, not invertible. But I'm going to go ahead and I'm going to restrict this domain. So what I'm going to do is I'm going to say we're going to start here and look just at this half of the graph. That is, I'm going to say that the domain is going to be from 0, and I'll include 0 because that's okay, on. So I'm going to say from 0 to infinity, which means in reality I'm only looking at this portion of this graph, right? Like that, right? And that's at 3, yes? So I know the domain is from 0 to infinity, and now I know that the range, and this is my original function, is from 3 and up, inclusive, right? Why am I doing domain and range? It's not because I hate you, it's actually because I want to show you, demonstrate a point here in just a sec. Now, How do we actually undo this? Well, I'm just going to do one technique here, and this is the one you're going to see most, and if you look this up other places, you take the x and the y and you interchange them, right? So this becomes x equals 2y squared plus 3, and then you solve. So we'd have to subtract 3. All we're doing is undoing what was happening, right? And this is almost the same as the last one, except for one extra special procedure, because now we're dividing by 2, if that seems familiar. How do we undo squaring things? We take the square root, which means that, let's go here. That means that y equals the square root of x minus 3 over 2, which is what the inverse is. Now, here is where the fun really begins. You ready? Remember, we have here, this is the original x and this is the original y, and then we switch them, yes? So now, what is true here? This is, well, let's take a look. What does this function look like? What does the square root of x minus 3 over 2 look like? Well, it looks like a function such that, well, so we know square root functions look like half a quadratic, right? But this thing has been whatted? Well, when we take the square root, we can take the square root of 0, right? That's fine. But where does that happen? Well, when does 0 happen? When x is equal to 3. So when x is equal to 3, we're looking that being 0, right? And then what? Well, then it actually heads off kind of like this. Now, if you take a look at that, because this is the inverse, right? What do we notice? Well, what's the domain? Well, it has to be 3 and up, doesn't it? Otherwise, because if we put in like, if we put in 2, then this becomes negative, which is impossible. And then what is the range? Well, it's starting at 0 and then heading off to positive infinity. Now, if you compare these, you'll notice that the domain of the original function became the range, and the range of the original function became the domain of the inverse. So to sum up, the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. This can save you a lot of grief when you are indeed finding inverses. And that's my brief primer for finding inverses.